Not all technology products are the same, of course. A smartphone touchscreen is not like a data center, for example. And these different end-use products have very different computing needs and therefore require very different semiconductors. The three main types of semiconductors are logic semiconductors, memory semiconductors, and a group of others, most commonly called DAO. Logic and memory chips are more complex, and so are almost exclusively integrated circuits, meaning they involve a complex combination of millions of transistors per chip. Conversely, semiconductors in the DAO group are simpler, often involving a smaller number of transistors, often in the hundreds or thousands. Logic semiconductors, which make up 40 to 45% of the market, are designed to compute logical operations. These are based on true or false calculations or combinations. For example, AND statements, which test if two inputs are both true, or not AND or NAND statements, which test if both inputs are false. Logic chips are used for complex functions, for example, mathematical calculations. Some logic chips in particular play a specific role in managing the data processing logic and control for an entire device. These logic chips are known as microprocessors, and there are two main types. CPUs, or central processing units, are like the computing brain. They run the operating system. A device such as a smartphone will usually have 2 or 4 CPUs built into a single chip. The second main type are GPUs, or graphics processing units, which handle image processing like video playback. A phone might have hundreds or thousands of GPUs. Next, let's look at memory chips, which make up about 25 to 30% of the market. As their name implies, they're designed and optimized for data storage. The two main memory chip groups are ROM and RAM, standing for read-only memory and random access memory, respectively. ROM can be used to store data permanently, longer-term memory. RAM, conversely, is shorter-term memory and can be used to store interim data, for example, while calculations are processing. Last, let's discuss the other group of chips, or DAO. DAO stands for discrete, analog, and optoelectronics. These account for 30 to 35% of the market. Discrete chips are used only for a single type of task, unlike integrated circuits which can manage multiple and more complex tasks. For example, a discrete chip might be used to manage power usage in a battery. Analog chips are used specifically for converting non-binary information, like audio inputs, into binary code, ones and zeros. These are like the translators. They allow the digital world to speak with the analog one. Optoelectronics chips play a similar function, but for visual inputs and outputs. They translate light into digital signals and vice versa, for example, in a TV remote control. In reality, these different types of chips will often be used together. In a given device, a logic chip will carry out calculations, a memory chip will store the data, and an optoelectronic chip will transmit the data via a light signal. How these chips are used varies across end-use technologies. Chip industry revenue can be divided into 4 roughly equal parts according to end-use cases. Mobile phones, data centers, and PCs and laptops each make up roughly a quarter of chip industry revenue. The remaining quarter comes from simpler consumer electronics, such as fridges, industrial and government uses like aerospace or military equipment, and importantly, automotive applications. Each of these device segments requires a mix of semiconductor types, but in different proportions. All device segments require a significant proportion of logic chips. This is like the bread and butter of any complex electronic product. Data centers naturally require additional memory chips, and devices like cars, robots, and satellites, which rely heavily on sensors, use a higher proportion of DAO chips. Given the growth of smart vehicles, drones, and satellites, the DAO market is expected to continue to be among the fastest growing. The size, speed, and cost needs vary by end-use segment as well. For satellites, for example, the value is on speed more than small size or low cost. They have plenty of space for tiny chips, and the chip will be a small proportion of the overall cost. A phone, on the other hand, needs to be small, fast, and low cost.